Welcome back to Science Click. Today, the Standard Model. The Standard Model brings together all the elementary particles which make up the universe in one single theory. Elementary particles are fundamental elements at the base of the entire universe. They are the smallest particles. They cannot be broken down or divided. The Standard Model sorts out these elementary particles in different groups. Firstly, the universe is made up of matter. Matter is fundamental to living beings, planets, stars, and everything that has a mass. The elementary particles which make up matter are named fermions. There are two main categories of fermions: quarks and leptons. The quarks and leptons that make up all matter exist under three different forms, which we call generations. To each generation is associated a pair of quarks and a pair of leptons. The first generation is made up of up and down quarks, along with two types of leptons, electrons and electron neutrinos. These are the most common particles found in our universe. When they bind together in groups of three, up and down quarks form the protons and the neutrons, which are the essential components of the atomic nucleus. Electrons are also present in atoms, orbiting the protons and neutrons. Their negative charge cancels out the positive charge of protons so that matter can remain neutral. By travelling in electric wires, electrons are also responsible for electricity. Finally, electron neutrinos are the matter particles most numerous in the universe. Over 1,000 billion go through our body each second. They have the property that they do not interact with matter, which makes them very difficult to detect. The second generation of matter is made up of charm and strange quarks, along with muons and muon neutrinos. These four particles have a mass that is greater than those of the first generation. Finally, the third generation is made up of top and bottom quarks, along with tau and tau neutrinos. These four particles are more massive yet compared to the two first generations. The particles of the second and third generation are very rare in the universe, which is almost entirely made up of first generation particles. Following on, all matter particles exist in either of two versions. Indeed, there is another form of matter, which we call antimatter, which associates to each particle an antiparticle. Antiparticles have the same characteristics as normal particles, but their electric charge is opposite. Finally, there are particles which are not constitutive to matter, which we call bosons. A boson is a particle which will act like a messenger to enable the interaction at a distance between two matter particles. Four of these are named gauge bosons. These gauge bosons each represent a force in the universe. The photon is the gauge boson associated to electromagnetic interaction. It moves about at the speed of light and gives rise to magnetism, as well as to light itself. The gluon is the gauge boson associated with strong interaction. This force plays out at a microscopic scale and is very powerful. It maintains quarks together, which themselves form protons and neutrons. Finally, Z0, W+, and W- bosons are the gauge bosons associated with weak interaction. This force underlies phenomena like the radioactivity of particles, or the nuclear fusion which takes place within stars like the Sun. There exists in the Standard Model one last boson, the Higgs boson. The Higgs boson does not really represent a force, but a field. This Higgs field gives a mass to the particles that go through it. The more particles interact with this field, the greater their mass. There exists in the universe a great diversity of elementary particles, which the Standard Model combines all together in a single theory. However, this theory cannot explain everything. For example, the Standard Model does not yet include gravity, which is essential to the universe. For this, physicists have suggested the existence of a boson which would carry gravitational interaction, the graviton. However, its existence remains only a hypothesis.